When I was 9 years old, I would go to my local library in the summer and I would always borrow this. I borrowed this tape maybe 20 times over the course of a couple years, and today I found a factory sealed copy. It contains many of the iconic home tornado videos of the 80s and 90s with a voiceover from a very dramatic narrator. But out of all the videos featured, I found myself rewatching this particular tornado over and over again. The tornado in question is the F5 that traveled from Heston to Gossel, Kansas. But this tornado is so much more complex and incredible than that single video shows, and today I want to explain why. 1990 was an absolutely wild year for weather. December 1989 was the fourth coldest on record in the United States. Starting in early December, multiple waves of Arctic air surged across the Midwest, reaching Texas and Florida, destroying citrus crops and causing damage to sewer systems. It was eerily similar to what happened 4 years earlier in 1985. The cold wave peaked on December 23rd when a low-pressure system dropped 15 inches of snow in Wilmington, North Carolina, and 4 inches in Charleston, South Carolina. Florida experienced their first white Christmas ever as snowfall in Tampa forced the airport to shut down. But as quickly as that Arctic air appeared, it then vanished. January 1990 was the warmest ever. For a large portion of the Midwest, temperatures were well above 40 degrees for the first several weeks of the year. But the hottest air didn't come until the second week of March. On March 10th, a ridge of warm air began to build, slowly creeping northward from the Gulf. By March 12th, it was 88 in Greenville, South Carolina, 78 in Cincinnati, Ohio, 69 in Wichita, Kansas, even 66 at Minot Air Force Base in South Dakota. When it's that warm in mid-March in the plains, you know some sort of energy release is bound to happen. A surface low-pressure system was developing to the west over Colorado that evening. You see how at the surface in Oklahoma and Kansas you have winds at about 15 knots coming from the south? That southerly air is very humid and provides the moisture needed for thunderstorms to develop. Stretching out to the northeast of the center of the low was the stationary front, dividing the warm moist air from the Gulf with cooler, drier air from the Rockies. This front was stationary for now but would blast off to the east in a couple of days. And of course to the southwest you had your cold front, which would eventually rocket off to the east. The National Severe Storms Forecasting Center saw what was happening and decided to issue a moderate, or level 2 out of 3, risk for severe weather across the Great Plains, mainly Kansas, Nebraska, and Oklahoma. Now, on the day and night of the 12th, you had storms firing off along the stationary front, which is pretty normal because, as we'll soon learn, storms love boundaries. Some of these storms actually produced a couple weak tornadoes. By the morning of the 13th, the conditions were a bit more alarming. Surface temperatures were very, very warm, and cooler temperatures aloft meant that once that surface air could break through the cap, it could freely and violently rise to 60,000 feet. The wind was also changing speed and direction with height in the lower portion of the atmosphere, meaning that any storms that would form that day would be rotating. So, all the atmospheric features of a classic Great Plains tornado outbreak were in place. Remember how I said storms like to form along boundaries? Well, when people think of the word boundary in terms of weather, they think of the boundary between warm air and cold air. While this is very important, there's also another important boundary, and that's between humid air and dry air. This is called the dry line, and it is critical in forecasting where supercells will form. The dry line doesn't supply nearly the amount of lift that a cold front does. A cold front forcibly shoves all of the warm air in front of it through the cap, which is why squall lines along cold fronts are so common. There is a greater difference in density between warm air and cold air. But with the dry line, the moisture content along the boundary will vary, but the temperature will stay the same. The difference in density between moist and dry air is much smaller than between warm and cold air. So only certain parcels or sections of air along the boundary are able to be forced through the cap. This ultimately leads to fewer storms. One might think that's a good thing. Fewer storms means less people in the path and probably less damage. But it's actually the complete opposite. Discrete individual supercells can and do produce violent, long-track, deadly tornadoes. And so the dry line is often a coin toss. Because the upward forcing is a lot weaker than with a cold front, you can often end up with no storms at all. They call this a blue sky bust in the storm chasing world. But if atmospheric conditions are right and discrete cells do form, it's going to be a long day. And March 13th was very long. There's one more important and unusual boundary that formed overnight, and it helped set the entire outbreak in motion. The storms that formed and moved across Kansas the night before were feeding off the warm, moist air supplied by the low-level jet. The moisture fell as rain, and the air became cool and dry, spreading out rapidly in front of the storm. This swath of cool air ahead of a storm is called a gust front, or an outflow boundary, and you've definitely experienced one before. This outflow boundary existed well after the storms had died off on the morning of the 13th, and was clearly visible in satellite imagery near the dry line. See how there are no clouds to the west of this line? That's cool, dry air from both the outflow boundary and the dry line. The two together likely enhance the lift of surface air to the east, allowing for more supercells to form, leading to more tornadoes. By 3 p.m. Central Time, storms were firing off all along the dry line boundary. One storm in particular started off as a collection of weak updrafts in extreme south-central Kansas, but over the next half an hour became organized, morphing into a single strong rotating updraft supercell thunderstorm with quite a large outflow boundary. Notice how there are no clouds within this small sector? At 4:34 p.m., this supercell produced its first tornado, touching down just to the northeast of Pretty Prairie. It was fairly narrow and weak at first, but it increased in speed, size, and intensity as it moved northeast over the North Fork Nenaska River. When the tornado was several miles to the southwest of Heston, many people recall hearing sirens for the first time and looking out their windows. At first, the sky to the southwest was dark and indistinguishable due to the heavy rain, but slowly a large tornado at the base of the storm became visible. Some students and faculty at Heston College, located in the west central part of town, realized that this tornado was standing still, but growing larger, which meant that it was heading straight for them. Now, a couple interesting things happened about a mile west of town. The storm produced a microburst just to the east of the tornado. A microburst is a very localized downdraft involving high winds and heavy rain that is being expelled from the base of the storm. Having occurred right next to the tornado, it actually did two things. First, the winds associated with the microburst caused the tornado to jog about a quarter mile to the north. This quarter mile was the difference between Heston College and downtown Heston taking F5 damage and virtually seeing no damage at all, which they didn't. The winds from this microburst also likely wrapped around the tornado, causing it to shrink in size, but increase in wind speed. So while the microburst may have saved the center of town, it made the tornado more dangerous for those on its northern side. Here are some photographs from residents on the north side of town a mere few minutes before the tornado hit. Kirk Alleman, the president of Heston College at the time, lived on a cul-de-sac in the northwest side of town. His house was completely swept away along with most other houses on the block. The tornado continued through town, hitting the Heston Machine and Welding Warehouse, as well as the Heston Decorating Company. And here is where Dean Allison's video comes into play. Located about a mile and a half east of town, Dean had the perfect perspective of the tornado as it crossed through town, missing the Heston Water Tower, then picking up a large cloud of powdered cement from the commercial buildings. This turned the tornado pitch black, the exact moment also captured by these photographs taken a mile away on Heston Road. On the east side of Old Highway 81, Croft Lumber and King Construction Company were destroyed, as well as homes to the northeast on North Main Street and North Weaver Avenue. Continuing to the northeast, King Park on North Ridge Road took a direct hit, and the Pizza Hut on East Lincoln Boulevard was leveled. Around 20% of the town was uninhabitable. That's about 80 houses and 15 businesses. Another 80 homes suffered considerable damage. Now, this is where things get insane. As the tornado was crossing Interstate 135, a second tornado touched down less than a mile to the east. This second tornado was part of the parent mesocyclone and slowly intensified as the Heston tornado started to weaken. As the two tornadoes grew closer together, the Heston tornado started to rope out and rotated around this new tornado, eventually getting fully absorbed into circulation. This is called a tornado family, a sequence of tornadoes, each with its own unique path produced by a single thunderstorm. This second tornado traveled another 20 miles to the northeast and was even more intense than the Heston tornado. In fact, out of the 350 or so tornadoes that Dr. Ted Fujita had surveyed up to this point, he said it was the most intense he had ever seen. Unfortunately, there aren't many videos of this tornado, one because it traveled mainly over farmland, and two, everyone was really focused on helping those in Heston. While the Heston tornado may be the most notable tornado to occur on this day, this was a major outbreak, and one of the most filmed and photographed severe weather events up to this point in time. The Heston supercell continued to the northeast and produced several more tornadoes, one of which was rated an F2 that went through Pilsen, Kansas. Debris from Heston was scattered all along the path of this supercell as far as 115 miles away. To the north, a cluster of supercells were wreaking havoc on central Nebraska starting around 5 p.m. A large wedge tornado touched down to the east of Guide Rock and traveled between 120 and 130 miles before lifting near Schuyler. It's unclear whether this tornado was part of a tornado family like Heston or simply one lawn-track tornado. It clipped the small town of Lawrence, destroying 63 buildings. If it was indeed one tornado, it would be the longest tornado track in Nebraska state history. More surprisingly, there were 0 fatalities, unless you count the estimated 10,000 geese that were killed by the storm. To the north, several supercells dropped 5 more tornadoes, 2 of which were rated an F3, and one in particular missing the city of Grand Island by a couple miles. Chris Stoltenberg took one of the more eerie videos filmed on this day of this particular tornado, which touched down as a large cone to the west of the city. Located at the corner of West Abbott and North Engelman Road, just to the northwest of Grand Island, she was in the perfect position to capture the following videos. Listen as the tornado sirens of Grand Island echo through the fields. As the tornado grew closer, the multiple vortices that danced around the parent center became crystal clear. This is some of the best footage of a multiple vortex tornado up until this point, rivaling the Edmonton tornado 3 years earlier. A cluster of supercells in south central Oklahoma produced 8 more tornadoes, as well as an F3 just to the east of Waukeeta. This tornado was lit by the sun, giving it a bright white appearance. Another interesting occurrence from this tornado outbreak were the 14 tornadoes in central and eastern Iowa, as well as the tornado that crossed over into Port Byron, Illinois. One of these tornadoes was rated an F4, causing substantial damage in Worthington. Another F2 caused $2 million of damage in Ankeny to the north of Des Moines. The aforementioned Port Byron tornado was the furthest east tornado to occur on this day, and it was the subject of many home videos. One of them was actually filmed by current YouTuber Lampofilm in Cordova, Illinois. He actually has a fantastic remastered video of the tornado hitting his house, along with an interview and some commentary up on his channel. I'm gonna link it in the description. Definitely go check it out. March 13th saw a total of 59 tornadoes, but only resulted in 2 fatalities from the Heston tornado family, and in total only 89 people were injured. People were very weather aware that day, and it helps that the tornadoes, for the most part, avoided large population centers. A couple footnotes on Heston. Immediately following the tornado, the students of Heston College gathered together at the school, came up with a plan, and took action. The students walked up and down the streets of the neighborhood, helping each individual homeowner sort through the wreckage to find important personal belongings. For the next week, the students managed to help everyone who needed it. Donations of food, water, and clothing poured in from everywhere around the state. The community really came together, and it showed. If you enjoyed this video, if you enjoyed learning about weather in general, definitely like and subscribe. It really helps me out. It helps let other people know that, hey, this video is worth checking out. Let me know your thoughts in the comments below, especially if you experience this outbreak. And I will see you guys in a couple weeks.